So my question to you is about enzymes and proteins now. Now, first, just for people to understand, can we have biochemistry without enzymes?
No.
We can.
No.
If you just put some
if we're
biochemicals together, they wouldn't work. Yeah.
Life as we know it, no. If you want to,
No.
if you want to say life is something else, fine. If you want to say a drone is life, silicon is life, fine. But as we know it, no. You've got to have enzymes. That's one of the critical components. That's like saying, can you have a car without wheels? I mean, it's a critical component.
And is it true that the majority of enzymes are proteins, and that we need the enzymes to create the proteins while the enzymes themselves are proteins? Is this a true statement?
Yes.
Yeah. So I've made this. I'm sure I'm not the first one to make it. That there is a paradox there, because you cannot produce a protein from a genetic material without an enzyme like a ribosome, and they just completely neglect that the ribosome has other things other than the ribozyme. It has many proteins there, like 80 or something, from 50 to 80 or something, and they say it's RNA, and then you can. But when you look to the papers, you find that enzymes are mainly proteins, and that they manufacture proteins. So which one comes first? How do we solve this?
Right. The RNA, people will say you have a ribozyme, so the RNA itself can be an enzyme. But we have no demonstrated example of the ribozyme functioning without associated proteins. And you need to have the RNA to make the proteins. And so it's just a very difficult problem to think about how this came about. That's why I say we're clueless.
So if the second part of the question, Mike, is speculating that RNA was doing the enzyme's role rational, given what we know today?
Well, RNA, like I said, people will say that RNA can act as an enzyme, meaning that it can be a catalyst for other reactions. But it doesn't act as a catalyst without associated enzymes. So, and even if it could act as a catalyst, it's not going to be around very long. And once it breaks, and the chances of making that again are very small. People will say that RNA duplicates itself. It's only been known in primed and human-designed RNA to be very special in its design. So it's primed and ready to go. It can only duplicate 10% of itself, generally less than 10% of itself. So that's not a duplication. So this whole idea, well, RNA, once you have it, it starts duplicating itself. No, it doesn't. It might duplicate 10% of itself in the best of cases, but that doesn't do any good. And that 10% is not sufficiently long enough to act as a new duplication template.
Is it correct to say that when somebody just says a blunt statement like RNA can, autocatalytically replicate itself, that this is a dishonest statement?
Yeah, I don't know that they're dishonest, but they're uninformed.
Okay, but if the person who is saying that is, supposedly informed, if he is posing as an expert in the field, how would you describe such a statement? Is it deceiving to the audience?
Well, it's certainly misleading to the audience. I mean, if someone called them on it or called her on it, I would expect them to clarify that even in the best of cases, only 10% has replicated itself, and that we have no example of the RNA acting as an enzyme carrying out these sorts of functions without associated without associated proteins. I would expect them to say that.
So let's take it this one step forward, because I came to know that proteins, just if you have this peptide chain, it wouldn't be enough. They need to fold and have this 3D structure that has the real properties, and that this protein folding process is such a big deal, and that the folding process itself involves enzymes. So I'm thinking like this: if by a stretch of imagination, I accept that one protein that is beneficial has been created through a random mutation or a series of random mutations, is it rational that we expect that even the enzymes and the other, it goes into, whatever, Golgi apparatus or something, to fold it properly, and it will find the right enzymes that will continue the process or if it's just a beneficial protein, it will automatically find the proper folding mechanisms. Does this come for free? Is this a free lunch, or it needs a complete system design? As a chemist, what's your comment on that?
Well, certainly we know today that many enzymes do not fold properly into an active state without chaperones. And those chaperones are other enzymes which help them to fold into the structure they need folding. So there's a paradox there within the field of biology about how these proteins folded. And so there's a lot of study. Protein folding is a big field of study, and how you can get these proteins to fold. There are some proteins that don't particularly need chaperones, that they can go into lipids and fold properly. So some proteins need other proteins to help them fold. Other proteins other enzymes don't need that sort of assistance. It just depends on the ones that are there. But in order to get them to fold right, it does have to have the backbone sequence to be right. And if you get that backbone sequence wrong, I mean, things start getting mixed up. And especially things that are somewhat near the active site, or things that are key to help it to fold. So there's a real problem. It's not just the how it's going to fold. It's how you got those specific amino acids to hook together into the chain originally. Very hard to fathom how that is done. Very hard to think about how that's done without enzymes being able to hook those together. Because without enzymes, you have active side chains on many of the amino acids, and those would participate in the enzymatic coupling in ways that are deleterious to the whole structural backbone. Real problem. And we don't have answers to that. Maybe someday we will, but we just don't have it right now.
So when people talk about, all what you need is a series of point mutations, and you have all of those new protein innovations, is it correct to say that this is not a complete representation of reality, completely ignoring other things that you talked about, like those chaperones, like the folding problem, like needing a complete system really to make this thing work?
Yes, you need a complete system. So it has a point mutation, and it's going to start making enzymes from that point mutation. Then you have another point mutation, and another, and another, and another. And then you have to translate that to RNA using enzymes to translate that. So DNA translates to RNA using enzymes. And then that RNA has to translate to the amino acid sequence using enzymes. And then how it's going to get the assistance to have those enzymes fold is unknown in many cases. And so, yeah, I mean, it is a system. Anything you change over here affects what happens over here. And so many times you have to think of concerted lines of evolution. Things cannot happen in isolation. You would have to have several lines of concerted evolution happening all at the same point in time, at the same time, for something to build. And we know that even within evolutionary scenarios, those are slow events that are occurring, but now you have to have many of these coming in all at exactly the same time. It's very hard to fathom. You have to have a lot of faith to be an evolutionist. A lot of faith. I'm not sure I have that much faith.
I think they offer the antithesis of that. They say you just need to believe in science. No faith involved.
It's
right.
faith. It's faith at every step.
It's faith at every step.
Yeah.
Except that there's nothing to have faith about, because there's nothing. So anyway, so I'm just worried about time. I wanted to ask you about cell membranes and the proteins there, but I will maybe we'll have another discussion about that. But let me ask you this: some are giving up on the RNA-World hypothesis. So this one was about if cell membranes needed proteins, and where would those come from? And since you need them for the membrane, then you need the proteins in the membrane, and the proteins need the DNA, and then you need the enzymes, and then if you don't have the membrane at the beginning, you don't have a cell. So it's a paradox. So in a nutshell, would you agree that this is a paradox on its own, that you need proteins in the membrane and you cannot have a cell without the membrane? And
Absolutely, absolutely. So these things of protocells where they just have a lipid bilayer, which you make by applying shear forces to a lamella. It's not how soap works. Soap does not have a bilayer membrane. Soap has the hydrophilic things on the outside, hydrophobic ones on the inside. The lipid bilayers have hydrophilic, water-loving things both on the inside and the outside. So you have a lipid bilayer. Some people get confused between what a cell has in a lipid bilayer and what soap does to have a monolayer where you have polar on one side, non-polar on the other. But in any case, to have this, it can't just be that you can't just be the lipid bilayer. You have to allow certain things in and certain things out. So you have to have proton gradients. You have to allow certain things in, certain protons out, and this is all controlled by proteins that are opening and closing and controlling all of this. These are highly complex structures. And the other thing is you need enzymes to make the lipid bilayer, because lipid bilayers cannot be symmetrical. They have to be non-symmetric, meaning the outside has to be different than the inside. If you just take lamella and put them under shear, you get some symmetry between the outside and the inside. That would not be suitable for a cell. You have to have asymmetry across this. And the asymmetry right now we know is induced biologically by enzymes called flipase enzymes that flip certain things to the outside and certain ones to the inside.
It just gets more complex as you go, doesn't it?
Yeah. So where are you going to get your lipid bilayer if you don't have the enzymes to do the flipping for you? It's a real problem. And people will say, well, they were much simpler in the beginning and those things just evolved. No, that cannot have been, because you would not have been able to have the proton gradient to have your simple cell. So you cannot keep throwing this right at the feet of evolution and say evolution took care of this, or evolution becomes your God. You throw it at the feet of evolution, evolution took care of it. Well, how is that any different than just making evolution then your God?
This is actually the next question. So I just pursuing this RNA-World hypothesis, and it seems that some people are, letting go of it, and they say it wasn't RNA alone, but peptides and RNA just evolved side by side, and it's a love story. And they have those drawings. It's not mainstream yet, of course, but does this solve it?
No, because hydrolysis of peptides means the breaking up of peptides is faster than the formation of peptides when you don't have enzymes putting them together. And chemists will say, oh, we do it all the time without enzymes. Yes, because you activated the end of one and you had the other thing protected, and you set it up to do that, and you protected the side chain. How do you do that when you don't have a chemist acting upon it? Nobody knows. Nobody knows. So if
you don't have a chemist and you don't have an enzyme, you're hopeless. Is this what you're saying?
Yeah. I mean, it's really hard to do this, and so the hydrolysis rate is going to be faster than the formation rate. And chemists that say, oh, well, these things can happen, we'll dissect their chemistry. This is going to happen. We'll dissect the actual chemistry that they did, and we'll take a look at it. And the nice thing about a real chemist is that when you point something out to them, they'll concede. They'll concede. I mean, because you just can't argue against what's there. And so even the real chemists that are picking on me, it's for very tangential things. They haven't gotten to the heart of anything that I said in that video. Because if they listen to that video, they're going to go, wow, he was right. He was right, over and over again. And those that have contested it will expose it.